what is the distance between a video and me? So, distance matter in artificial intelligence. What is a distance? We know how to measure a distance between two cities. We know how to measure a distance between 2 points. And you can use a ruler and you can use mathematics. And when you're using mathematics, this is called topology. So why do I want these distances? Because when I have distances, I can answer more complex questions. I can say, which is closest? Is it easier to get from here to Dublin or to Ljubljana? Or I can ask myself, which is the best way to go from one place to another? So a number of questions can be answered because I've actually got a map and because I can look at distances. One of the best known distances is called the Euclidean distance. You have all learned this at school. On this slide you can see the mathematics, which are the simple mathematics that go with it. So if I've got for the city of Dublin and the city of Rome 2 coordinates, I can apply a typical equation, and using this equation I can then transform the coordinates into kilometers or into miles. So much for geography. What happens in the rest of the operations? Well, interestingly, I can build distances based on something else than just the physical distance. I can build it on the features that will somehow represent the objects I'm interested in. Suppose, for example, I'm a travel agent and I want to sell in my catalogue the city of Rome or the city of Dublin. So I may know things. I may know how much it rains in each city. I may know how well rated the hotels are. I may also know how much my holiday costs. So these would be 3 features which allows me to define the city of Dublin, or my trip to Dublin, or my trip to Ljubljana, under these 3 dimensions, as in the picture on the slide. And again, I can use the Euclidean distance, which is just the mathematical formula we had in the previous slide, to compute the distance between these 2 cities. So you just do the computations and you end up with a magic number, 1.3. What is interesting with this 1.3 is not that it actually means something, but that it can be compared to another magic number, which will be the distance between Paris and Brussels, for example. So how to build distances? So the first thing we have to do is build it upon features. Features are elements I am going to extract from whatever I want to measure. So if I take a rabbit, for example, I might be able to measure the length of the ears. I may be able to know the age of the rabbit, in months presumably, and also, why not, the quantity of carrots it obtains per day. And in that case I can give for each rabbit an associated vector, which is just a set of numbers. For each one of those features there is one number, and I have this vector which defines in a way the rabbit as belonging to 3-dimensional space. Let's take another example. Anna is a girl. She is aged 14 and she's had 8 good grades. Beppo is a boy. He's aged 16 and he's got 6 good grades. If I decide that the value 1 is associated to girl and the value 0 is associated to boy, I now have a vector for Beppo and a vector for Anna. And as in the previous example, I can now compute the distance between the 2 vectors, which actually is going to be for us and for this application, the distance between Anna and Beppo. I'd compute this using exactly the same formula, and I obtain the result 3. 3 isn't the number of kilometers or the number of meters between these 2 children. 3 is just a number that has only got value when I've got other children and I need to do sort of 2-by-2 comparisons. So let's have more details. The Euclidean distance is just one of the distances. The mathematicians have invented hundreds and thousands of distances. And we can do what we've just done here, not only between persons or between cities, but between texts. I can, for example, take a text as just being the sum of all the words that are in that text. And for each word in that text, I can count how many times it appears. So each word is a dimension of a vector, which now is not going to be of size 3, but probably of size various thousands. And I can again compute the distance between the two vectors. And again, if we have twice the same vector, we realize that we're going to have a distance of 0, which is what we want. So two texts will be similar when we have a very low distance, and two texts will be seen to be different when the distance is very, very large. So up to now, we have compared children with children, we have compared rabbits with rabbits, and we've compared text with texts. But we can actually compare people with texts. We can make the hypothesis that a person is what she has read. And if I take, let's say, the 5 last books that I have read, those 5 books can be seen as one gigantic text. And I can do the same reasoning as before to be able to have, again, a vector representing me as in me being the text that I have read. And I can now compute the distance between me and various books. And this may be used to recommend which is the next book that I should read. The same can be done between a person and a video, of course.